All right, here we have section 6.4, which deals with rectangles. So there's our main ideas, one new vocab word. So rectangle is a quadrilateral with 4 right angles. Since both pairs of opposite angles are congruent, it's a special form of a parallelogram. So a rectangle has all the properties of parallelogram. In addition, the diagonals are also congruent in addition to bisecting each other. So here you go, theorem 613. If a parallelogram is a rectangle, then the diagonals are congruent. So AC and DB are congruent to each other. Just some more reminders of properties of rectangles. So first off, opposite sides are both parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, so A plus B is 180, B plus C is 180, so on and so forth. Diagonals are congruent and bisect each other. So the bisect each other part is a parallelogram property. The congruent part is a rectangle property. And lastly, all 4 angles are right angles. So A, B, C, and D are all right angles. So example 1 here, quadrilateral MNOP is a billboard in the shape of a rectangle. If MO is 6x plus 14 and PN is 9x plus 5, find x, then find NR. So here's MO, bottom left to top right. Here's PN, upper left to bottom right. So they are the 2 diagonals. Since this is a rectangle, those are equal to each other. So bring the x's to the left, move the numbers to the right. So x is 3. So once NR, now NR is only half a diagonal, so I have to find the length of NP first, and then I can find the length of half of that. So NP is going to be 9 times 3 plus 5, so that's 32. That's 27 plus 5. So divide by 2 to get half of it, which is 16, is what NR is. Okay, example 2, once again we have a rectangle, says find x, find y. So if you look at the x's, they're up here in corner A, so there's 9x plus 20, there's 4x plus 5. So since they are both in corner A, they have to add up to make 90 degrees. So I'll try not to slide it off the edge here. So 4x plus 5 is equal, plus 9x plus 20 equals 90. So that's 13x plus 25 is equal to 90. 13x is equal to 65, so x is 5. So now if I know x is 5 and actually figure out what that is, that angle is 25, that angle is 65. So find y. Now the other trick I can do is this corner down here is the same as that corner there, which is the same as that corner, which is 25. So I can set 4y plus 4 equal to 25. So 4y is equal to 21. So y is going to equal 5 and a quarter, 5.25. So rectangles, this is just the reverse of 613. If the diagonals of a parallel are congruent, then it is a rectangle. 613 was, if it's a rectangle, then the diagonals are congruent. All right, so example 3, Trent's building a treehouse for his younger brother. He measured the window opening to be sure the opposite sides are congruent. He measures the diagonals to make sure that they are also congruent. This is called squaring the frame. How does he know that corners are 90 degrees? Well, if he knows that opposite sides are congruent, he knows he has a parallelogram. If he knows the diagonals are congruent, he knows he has a rectangle. And if he has a rectangle, the corners are 90 degrees. Last one here, example 4, given these vertices, determine whether that is a rectangle. So to do that, I'm going to actually use the slopes. So this slope from F to J is up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So this is 3 over 6, or 1/2. J to H is down 1, 2, 3, 4, and over 2. So negative 4 over 2 would be negative 2. G to H is up 1, 2, 3, and over 6. So that's 3 over 6, or 1/2. And this is going to be negative 4 over 2, or negative 2. Now if you stop here, you've proven a parallelogram, because opposite sides have the same slope. If you want to prove a rectangle, I actually have to multiply the 2 values together. If you get negative 1, it is a rectangle. If you get any other number, it is not a rectangle. And that's the end of the section.